Okay, guys, so the first thing I'm going to do is, or I'm going to go through question one, so I'm going to short questions. Okay, so the first question there, name part A and explain the purpose of part A. So part A is a few key things. I've drawn it here. Looks something like this. It's a spark plug is what part A is. Okay, you already got 2 marks for that out of 20. So spark plug, key thing to know about spark plug is, so again, your coils will go onto the sort of plug, and that would be made of aluminium or brass, because it can conduct electricity. You have a bit of ceramic, again, they usually, that is a good insulator from heat, good insulator from electricity, threads, and then you have this overreaching sort of piece of metal. And what happens here is your current's coming in, again, it's DC current, don't really need to know that, DC current, because it's coming from the battery, hits here. The thing about it is, it wants to go somewhere. Since there's such a small distance between the two of those, it jumps. Okay, and when it jumps, it creates a spark, and the spark ignites the fuel. So that is the function of it. So it ignites fuel. That right there, writing ignites fuel will get you 1 mark. You need to write it ignites the compressed fuel in the power stroke. That's what it is. So it's using the power stroke. It gives you the power. That's why you have your compressed fuel. Again, if it would ignite fuel, but all you have is a fire. Again, when the fuel is compressed, it makes an explosion. This pushes the piston down, giving you power. Again, this distance here, an older car that would be misfiring or something like that, that would be that could be one thing that's wrong with it, is that distance there is too great and the spark won't jump. So now you have no spark, you have no ignition, loss of power. Okay, the next one we're looking at, so explain, name part B. So part B is there. Part B for mechanics would be known as a conrod, but in what we need to know it as is a connector rod. Okay, so you have the key characteristic of an arm. You have one big socket that goes onto the crankshaft, one small socket that goes onto the piston. Well, not the piston, but the gudgeon pin. Okay, so I'll go through it now in a second. So what you have then is you have your drawing upside down. So here is that's your conrod. Okay, so your connecting rod or your conrod, whatever you want to call it. Again, in the exam, call it connecting rod. Function connects the piston. Well, it's the gudgeon pin, Gudgeon, to the crankshaft. Okay, so so again, 2 marks for naming it, 2 marks for explaining it. Again, if you said it connects the piston to the crankshaft, you might get the full marks. To make sure you get the full marks, gudgeon pin. Function of the gudgeon pin, it's this pin here that connects your conrod to the piston. Okay, so again, the function of just drawing this crankshaft here, what it is like a handle. So you imagine you're turning something. What happens is it turns, this thing is going to be going up and down, up and down, up and down. So it turns what you call reciprocal into rotary. So that is our power. That's what gives you your power. So again, so it turns reciprocal. So the piston's going up and down thousands of times per minute. It turns that into rotary. So again, that's where you get your torque from, is the amount of power and the amount of rotary you can get. The next question is name part C and explain how part C is open and closed. Drawing needed for that one big time. Okay, you need to be drawing that. Part C there looks like that. Looks like a golf tee on its side. What is it? It's a valve. Okay, so a valve. They're at the top of the engine, and what they do is you have one here, you have one here. So one is usually the left one. Again, just for the sake of argument, is your input. What's going in there is your fuel and air. On the right you have your output, or whatever you want to call it, your exhaust. And what's going out there is exhaust fumes. Okay, so it's just burnt fuel, burnt air. It's been used up in the explosion. Okay, so the valves, they're wondering how are they opened and closed. So what you have there is your 2 valves. Let me get another sheet of paper. You have what I'm focusing on here is I'm going to zoom in. I'm going to zoom in up here. What's going on up here? Okay, so that's what it looks like. You have 2 of them like this. Again, it's very important that I'm going to show you. So again, both of them would never be open at the same time. Different strokes. They would be, so again, on the intake, this would be open and closed. Then the 2 of them are closed. for the next stroke, 2 of them are closed for the next stroke, then this one opens, okay? So if we zoom in up to the top, so again, this is the top of the valve. What opens and closes it is an egg-shaped cam, okay? And what happens is, as that rotates, it's going to push that down. Again, this has a spring on it to make it shoot back. So again, the last thing you want it to do is to be pushed in, and next thing it won't come back. So it has a spring on it. So as this rotates, because again, if you look at this distance here, from there to there, again, that looks to be about an inch, whereas from there to there is about 2 inches. So again, that's how it extends. So as this rotates here, there's the pivot, so where it rotates. And again, what that will be doing is that will be connected onto the timing belt. And again, that's why if the timing belt goes in a car, that's why it's so deadly, is because this is pushing the valve straight down to the piston, and you get bent valves and you get damage to the piston and everything. It's a bit of a disaster. Okay, so that is, again, your engine question. You know they're coming up. 1, 2, 3, straight away. All you need to do is answer 5 of these. Now, lucky for us, it came up as a fourth one. So suggest a suitable material for the piston shown and list one important property. Okay, so that was a bit tricky. So again, your piston is down there. Okay, so again, a lot of people said stainless steel. Some people said steel. Again, it needs to be a tough material. Again, the problem with steel is it needs to be light. So again, steel is a bit heavy. Problem with steel as well is it'll rust. So if you leave that car out in the wet for over the winter, hasn't been touched in 2 or 3 months, that's going to be rusted up. You're going to be seized. So you need to think of a material that will not rust, and that's tough. And for the sake of it, like again, everyone's looking for lighter machines. For a light, it needs to also be light. So I'm going to get you to answer that question. I want you to come up with a material that is not going to rust. So again, it has to be a metal. Again, plastics would not last too long. It has to be a metal that will not rust, is light, and again, that will be our material. Okay, and then you also need to list a property. You also need to list a property of the material. Okay. The next thing we have 3 inventors. You always get these. You have Henrik Vogt, you have Douglas Clark, and you have Bill Gates. Bill Gates was the one that most people went for. Okay, so Vogt, what he was responsible for was he found helicopter. That's what he did. Clark is responsible for the 2-stroke engine. Okay, so for the likes of a lawnmower or something like that, so it's 2-stroke. He made that. Again, that was a very easy question if you knew them. And then we all know Gates. Gates is Microsoft. All the Xbox fans should have got that. Okay, so again, Gates, a lot of people said he made Google, things like that. No, he did not. He was the founder of Microsoft. Okay, so we're going to keep going. Nearly finished there. So we have explained the term ferrous metal. Okay, and name any two non-ferrous metals. Okay, so what you have is ferrous metal. What in the name of God does that mean? Just to let you know, a bit of science. Periodic table. Fe means iron. Okay, so that's where the word ferrous comes from. It comes from the word iron. So what you have is you have ferrous metals and you have non-ferrous. Ferrous have iron. These do not. These have no iron. So again, ferrous metals, you're looking at the likes of steel, you're looking at any sort of steels, even iron itself. So one steel that is not a ferrous, there's only one steel that comes over here to non-ferrous, and that's stainless steel. But all your steels, your mild steel, carbon steel, all these things that we use for the files, cutting tools, all that are ferrous metals. They have iron. Key thing about iron is it will rust. Problem with that's why if you ever look at galvanized iron and things like that, they will always rust after a bit. So again, that's why we galvanize iron. It protects it. You put a layer of zinc on it. So again, non-ferrous metals have no iron, so obviously no rust. So these are ideal for the likes of, again, sometimes you get them on doors, again, cars. Again, the last thing you want is a car that will rust. You want it to be you want the doors to last longer. So you have things like aluminium, copper. So that's why they use copper for piping. Does not rust. Tin. So again, that's why tin can be used for cans. And then, as I said, stainless steel. Stainless steel does not rust. And we're on to the last question. My thing is just glitched on me. Okay, so identify both electronic components shown. Okay, so the first one is what you call, I'll just draw it for you really quickly, 1 second. Look, something like this. Okay, and see, it has 3 pins on it again. It's the exact same as the thing, exact same as normal switch. You have to use the middle one and one of the other 2. Okay, and what that does is it's sort of like a thing. If something rolls up against it, it'll push this down and it'll knock it off or knock it on, depending on what way it's ironed, it's wired. Okay, so that is what you call a roller. So you have a roller here at the end. This is a lever. Switch. And so what that function of that is it moves when something hits it, it turns it off. Outline the function of one of the components, and the other one is a buzzer or a sounder, whatever you want to call them, speaker. You'll get the full marks for that. Again, both those. So identify, so it's 1 mark for identifying both of those, 2 marks for outlining the function. Same, explain the term non-ferrous metals, 2 marks. Name any 2, 1 mark for each. And then you got 4 marks for saying Bill Gates. All you have to do is say Bill Gates founded Microsoft. Straight away, boom, 4 marks. Okay, so that's question 1 gone through from start to finish. I'll leave you question 2 to do for me, and then I'm going to go through some other questions during the week. Okay, thank you guys.